So hi, good morning. Does anyone know a good joke that is okay to tell children? Surely someone's got a joke that you tell the kids. Nobody? There's one. Speak it into the mic so they can hear.
What is orange and sounds like a parrot?
What is it?
It's a carrot.
Man, it's okay, we took care of it. It's good. It's good to start with something kind of funny, but also safe. So hi, thank you all for coming. It's a lot more people than I thought would come in a multi-track conference, so nice. This is my name, I'm Samuel. Hi. This is where I'm from, in case you're curious. This is where I work. It's mostly just me, but that's where I work. This is where I volunteer. If you happen to be in Amsterdam or come by Amsterdam, we have this whole nonprofit organization to help developers in the city. So if you just want to talk to some other people, or you need some business connections, or you're curious about learning something and need some help, we have a whole system set up for that. So if you're coming through, then you should let me know and we can hook you up. Okay, so we've probably all heard that testing is pretty important. A lot of people think that it's the only way to make quality software, that like it's not possible to make something good without testing it. If you do write tests, then you can get this little cycle going where you write some tests, you make the test pass, and then you can refactor. But this is not super easy to do if any of you have tried. If you look for tutorials and books on the internet, you're going to find simple examples like this. And okay, this makes sense, right? Assert that this equals this, assert that this is true. Nothing super complicated there. But then when you go to use this in your real app, it's about like that famous tutorial about drawing an owl. You've probably seen this on the internet, I guess. Like this is not a very friendly gap here, and we're going to try to help make this a little friendlier. So when I first started looking for testing, it was about like this. A lot of developers in the industry were debating about whether or not testing was even necessary. A lot of the tutorials you would find would be really simple things and not really things that you could then go try to use to fix your app. And in order to find these things, I had to start to look outside of the iOS ecosystem. So this is Sandi Metz. If you haven't heard of her, she's pretty great. A lot of people would quote her as one of their heroes. She gives talks mostly about Ruby type things, about object-oriented design and testing. And her talks about testing were some of the most helpful talks I've ever seen. In the Ruby world, they have no compiler, they have no like static checking at all, so testing is one of the few tools they have. So they're real big into it. So it's a good place to go for information about how to strategize about testing your product and organizing things so that they can be tested. Another one that was super useful was this Java book. And like iOS developers like to joke about Java because it's funny and it's big in the enterprise or whatever. But it's actually a super useful book. This book, they walk through building an actual functioning application using test-driven development. And so you see their testing strategies and how that applies to a real thing that's really going to be distributed to somebody. And they follow along with making changes to the application and updates, and how the tests signal that things are going to break if you change things in that way, and how you can change things so that everything is going to be okay. So this is a really good book. You should find it somewhere and read it. It's well worth it. But so I assume most of you are iOS developers or Mac developers, right? Maybe you're Android developers and you're curious because this is a multi-platform conference. Good, there's at least one of you. So we're going to get into some tips on like actually doing things in Swift so that you have some concrete usable things when you leave. So first, you can make custom assertions. If you have tests like this and they start to accumulate a whole lot of assertions, you're checking all these different parts of your model to make sure it's set up correctly. You can build custom assertions like this one, which is kind of big, but this allows you to group those assertions into one so that you can instead just say, assert that this is valid, which is a lot easier to read. And what actually constitutes valid can be encoded in this test function that says, these different requirements need to be met. So this makes your code a lot easier to read, and that way people are less confused when they see your test and try to do anything with them, which is good for encouraging people to actually do something with them and maybe write some more tests of their own. It's basically impossible to write code and avoid singletons. A lot of people shout that they're the devil, but like the system provides a bunch of singletons, and we kind of have to use them in order to make a functioning app. So if you turn those into, if you replace this with this, where you turn that singleton access into just property access, then you're free to replace that property with whatever fake version of the singleton you want, and you can test that your things will still work like they're supposed to. Once you're doing that, if you're using things like the core location manager, you have class functions that you have to call as well. So you can change in the places in your code where you would just call location manager dot is location available with something like this. So this will make it to where when you replace that property with your fake version of the location manager, then you'll still call the class method of your fake. So that way your test can cover things like what happens if the user refuses location permissions, what happens if the user doesn't have access to a camera for some reason, things like that. You can also run your tests in playgrounds. Some people are really big on playgrounds and want to do everything in playgrounds and only in the very end move that into their actual project. So if you add this line here at the bottom, then you can just run your test suite in playgrounds. That by default, the output of your test will just show up in the console underneath your playground screen. But if you implement a custom test observer with this really long method, and don't worry, the slides will be available later, so you don't have to actually memorize this now. But if you implement this really long method, then you can choose to do whatever you want when a test fails, rather than just spewing it out on the console. So in this example here, we trigger an assertion failure, which would show in your playground that it actually crashed at this point. So it's a little more apparent that a test failed. You might also write tests that depend on things like a UI navigation controller. Maybe you want to test your initial sign-up flow and make sure that you ask for the appropriate permissions and get the right details from your user. These tests won't work by default, but if you add this in your setup at the beginning of your tests, this makes it to where the navigation controller will actually behave the way you expect, so that you can assert that the appropriate view controllers are piled up in your navigation controller. You can also test asynchronous things. And you've probably seen the basic example, right? We make an expectation. At some point later, we fulfill that expectation, and everything is good. But you can have cases where you have asynchronous work that is being done that you don't have just a convenient completion handler for when that work is done. So you can make expectations based on a predicate, which will trigger your test suite to watch an object using KVO so that you can see when a certain property changes, and whenever this predicate evaluates to true, that's when the expectation will fulfill. So in this example here, my thing produces a progress object. Progress is convenient for reporting the progress of actions. You can build trees of progress objects, so if you have subtasks and subtasks of those subtasks that need to get done, you can track the overall project. You can easily link these to UI with the KVO as well. So in your test, if you want to make sure that your progress eventually does finish, this is how you would do that with a predicate expectation. You can also run tests that depend on core data. You're generally going to want to insert a special context that uses an in-memory store, because if you're using just your regular store, then your test data that you insert or delete will potentially override or conflict with the data that's actually part of your application. This also would make it to where each of your tests were dependent on each other. So you can eliminate that by setting up a new context for each test. And so I like to make a sort of test function that creates the in-memory context like this. And then also, while you're at it, go ahead and create and return any dummy objects you need for your test. In this example, I'm making a test that does something with core data and the stored account data. So if I go ahead and just return the account as part of the creation of the dummy data, then I don't have to start my test by first executing a fetch request and making sure that I get data back and doing that whole dance. This will make things a little faster for you. You might have some shared fixtures or some sort of data that you need for each of your tests. And in Swift especially, it's really simple to just do this at the top of your test. And now write a bunch of tests that use this fixture. But then share data between tests, make it to where your tests depend on each other. And that's how you get things like flaky tests or inconsistently performing tests. So it's better to replace that with a variable and then use the setup function. The setup function will execute before each test starts so that you can create a fresh new fixture. And that way, you're not sharing data between tests, and your tests can work in independence. There's also a teardown function if you need to delete some files that you created, things like that, when you're done with each test. This gets executed at the end of each test in your suite. Also, I don't know if this existed in Objective-C, but they added it in Swift. You can add teardown blocks. So in a test, for one specific test, if you have some extra work that needs to happen when the test is finished, you can schedule that to say, also delete these files that you created just for one single test. There are also class versions of setup and teardown. These will execute at the beginning and the end of your whole file of tests, your whole suite. And so if you have like environment variables you want to set up, so you say, I want to run these tests, but I want to enable super debug logging or something for this group of tests, then you can set that up and then turn that back off once that group of tests is finished. Once you have all these things done and you have a number of tests, one thing you're going to want to turn on that they've added recently as well is the randomizing order of tests and also executing your test in parallel. Randomizing the order of your tests helps to make sure that you don't accidentally write tests that depend on each other and can often expose like weird race conditions or dependencies that you have that you didn't think you had. Because if you run the tests in the same order every time, then they might work and you might not notice that the second test only passes if the first test runs first. So the random order will help with that. And then executing them in parallel will just make them go way faster and also potentially expose some weird race conditions in your code. If you do this and you find that you have flaky tests, it's probably because you have some place in your code where you're doing some kind of threading wrong, or maybe you're accessing some shared file on disk that you didn't realize. When it parallelizes tests, it groups your tests still by test suite, or test case, I guess they call it. So for iOS, it will make clones of your simulator and launch 9 or 10 of them, depending on how many tests you have, and take each suite of tests and throw them to a different simulator. So if your tests are all in one suite, then this will do nothing for you, and it'll be exactly the same as it was before. But if your tests are separated so that you have a suite of tests here for this object, and a suite of tests here for this controller, and a suite of tests here for this whatever else, then those will get spread out among a bunch of different simulators and all run at the same time. So your battery of tests that used to take 3 minutes to execute now takes maybe 30 seconds, maybe 20 seconds. Because an important part of testing is to make your tests run as quickly as possible. If your tests are very slow, then no one wants to read them, no one wants to look at them. I once met an engineer who worked on Chrome years ago. I don't know if they still do this, but they took turns on the team where one person was responsible for watching the CI server. And so everyone is writing code. Maybe they run a few tests locally, but the whole test suite for Chrome takes something like 3 hours to execute, maybe more. So no one is going to do that locally on their machine before they make a change, right? So everyone makes changes, everyone pushes those changes, maybe they get reviewed. But so one person's job on the team on a given day would be just to watch the CI server and wait for a test to fail, and then go and figure out who introduced the code that causes the test to fail, and then go ask them to fix it. Like, you probably don't want this in your app. I mean, I don't think most of your apps are as complicated as Chrome, so it probably doesn't take quite that long, but the faster you can make your tests, the better, and parallelizing them will help a lot. This also works on Mac apps. It's really weird to see like 6 copies of your Mac app on your desktop at once, but it does work. So here's a collection of the resources that I have found that were super useful beyond the book and the conferences earlier. Here's Sandi Metz's conference talk. When you get these slides later, you can watch that, which is really great. I learned a ton about how testing works from that. And yeah, if anyone has questions or something, I'm happy to talk about it. There's an extra mic, right? Cool. I don't even have to walk because people are helpful. Hi.
So what's your usual goal in testing? So you want to target the 100% test coverage, or you testing whatever makes sense? What's your approach?
I think 100% test coverage is maybe way more than necessary, and probably you end up writing some tests that are kind of a waste of time to write. But I think something like 20% test coverage means that you probably have a lot of room to write some tests. It kind of depends on the project. So I'm working on a Mac app for myself, and from the beginning I was testing that. So the underlying framework that I made is about 95% tested, and the Mac app itself is about 80% tested. But that's because I was writing tests while building it, which was really handy because there was a ton of places where I thought I was doing something right and I was not, and the tests helped expose that. But a lot of times for client work, I walk onto a project that starts with no tests, right? And then you're just trying to write some tests in the process of getting your work done. So then I would prioritize, if you get a bug report, write a test that reproduces that bug and then verifies that you fixed it when you fix the bug. And then you know, if you get bored one day or something, then go picking around for some low-hanging fruit. Because nobody wants to hear, like, stop everything, we're just going to write tests for the next week. Just like nobody wants to hear, stop everything, we're going to rewrite this whole thing. So you have to be sort of realistic about it. It'd be great if everything was tested, but especially if you start on some project that's been running for a couple of years and is not tested, then there's only so much you can do. But at the very least, the parts that I wrote, I would write tests for.
Yeah, thank you for your talk. And
Thanks.
About tests, do you use this like pyramid of testing when you have a lot of unit tests, a little bit more integration, and some maybe end-to-end tests? Or like which levels of tests do you use in your app?
I put most of my effort into unit tests because the UI test for iOS is one of the things that everyone complains about. You get sort of flaky tests that way. I've had some luck with those sort of tests just to make sure that you can launch the app and navigate through the core parts without anything crashing. But I haven't had too much success with super detailed UI tests, so I generally try to avoid those as much as possible.
Yep.
Hey, you have shown 2 features that are entirely new to Xcode 10 testing, which are
Yes.
parallel testing and the random order of the test.
Mm-hmm.
And I wonder whether you have any situation in which you have those 2 options have help you detect a bug in your code with the random order?
Yeah, so with the random order, I had issues where I thought I was cleaning up correctly after a test, but I was not, right? And so the tests were passing because they ran in this particular order. So when I first turned on the randomizing, then suddenly tests are failing, and when I go to look at why, eventually I find out, oh yeah, it's because this test is not cleaning up things properly. This is sharing a thing like they're both accessing user defaults or something in a place you didn't realize. Yeah, this sort of thing you'll probably find in almost any project the first time you turn this on.
Yeah, but it was more like in the test code problem, not in the production code, right? So not cleaning
No,
correctly.
well, in some cases it was the production code, right? Like if your production code is doing something with user defaults that you didn't realize, because that's the problem with singletons in general, right? Is that they can easily hide in places and you don't realize that, oh, actually, these are all talking to the same thing. So yeah, randomize that test order and then suddenly you see, oh yes, they actually are, and this test only worked because this one left something behind in user defaults or something.
Great, thank you.
You pass it right behind you, I think.
Hi, thank
Hi.
you for your call.
Thanks.
For your talk. I've got a question. You said about joining the projects where there are no tests at all.
Right.
But what about strategies for project with huge technical debt, where you have too many end-to-end tests and some unit tests and no integration tests? So we have a project where there are like 800 end-to-end tests. And
Wow.
if you would run it on one device, it would take 20 hours. So we don't know how to solve the situation. So have you any strategy for solving?
I wish I could be on a project like that. Sounds like really fun. Mostly I get on projects that just have 0 tests because nobody knew or cared.
So yes, we have like, so the testing pyramid in our
Is
project
upside down?
Yeah, it's upside down.
Yeah, well, so first I would try to make the tests that were there execute as fast as possible. I mean, maybe you're already doing all the optimizations to parallelize and speed them up as much as you can.
We do
But
that.
okay, well then, yeah, if it's still taking forever, yeah, I would probably approach it very similar to the way that you approach a project with no tests, which is right now we're working on this feature, so let's write tests for this feature. And then maybe some of those integration tests, because we wrote some like a local unit test here, we can get rid of some of those. Because 800 integration tests sounds probably like a lot of them are overlapping in what they're testing as well. So you could probably just look through and find some number of them that you could delete just because they're redundant. Yeah.
Okay, thank you.
Yeah. Are there other questions or? Oh, sorry, I guess I'm supposed to hand out mugs for people to ask questions or something. I have 3 mugs up here. So, yeah, I'm give some mugs out. What was your question in the back? Did you, oh, he had a, yeah. Can you pass this mug down to him?
Samuel, I'm working with some developers right now who have become hooked on snapshot tests. Well, they'll just screenshot the new controller and then compare future versions against that screenshot and say, is it the same? It's the same. The code's good.
Yes, yeah, screenshot tests.
Yeah, which is it's useful and it's valuable for certain things, but they're kind of hooked in it. Even for things where it's business logic, they think snapshots are a great approach. It's simple to do. Just do that. It's done.
Mhm.
Good advice for getting teams to think more carefully about unit tests, like really put more effort into them or more planning ahead for them.
Like more effort into making them in the first place or
Yeah,
making
pretty
better
much. Take it
quality
more
ones?
Seriously.
I don't know. It sort of depends on the team. Like I've worked on teams where you literally just walk in and you say, this is wrong, this is wrong, this is wrong, stop doing this. And they like that and they say, yes, thank you. And then they go to try to fix it. I've also worked on teams where like 6 months later they still don't give a crap and there's nothing you can really do to change their mind. You know, because they're people, and that's the hard part of programming, right, is dealing with people. So sometimes all it takes is for you to write some quality tests and then demonstrate how that was super useful, right? And say, oh, look, I exposed this bug in the AMP that was causing people to lose data or something. And then they all say, wow, that was so amazing. We should also write tests that probably expose some other bugs. Like sometimes that works to lead by example. Sometimes you just yell at them. I mean, I wear shoes that don't require tying, so I can throw my shoe pretty easily. yeah, I think it sort of depends on the team and the people. Like a lot of times I get hired to work with teams where on a team of 3 people, one of them maybe cares, and the other 2 are just doing it because it's a job and they're not really trying to do anything better. And like, unless something super inspirational comes along, I don't know if there's much you can do to really change their opinion about their work. So yeah, I don't really know what you can do to try to talk them into it. Sorry, handing out more mics. Can you pass this down, Dan? Thank you. Is that all of the questions? Yes? It's okay if you have like weird questions that sound dumb or something. I like dumb questions because I don't have to try very hard to answer them. Yes? Assert 2 equals 3. It'll fail. Okay, well, cool. Thank you all for coming, and thank you for the questions.